Hey guys, so today what we're going to talk about is the second part of the weather variables PowerPoint. So yesterday you did part one and you did part one notes. Today you're going to do part two notes. Then do part two of the exit ticket and you're done and have a wonderful weekend. But let's get to part two of the PowerPoint. Okay, so today we're going to talk about humidity, relative humidity, and dew point. Those are the last three variables that we have to talk about. I'm sure you know what humidity is, or you've heard, oh, it's humid out today. But we're going to dive into what that really means. So the definition for humidity is the amount of water vapor in the air. So how much water vapor or gaseous water is in the air? When it's high humidity, it means there's more water in the air, more gaseous water, more water vapor present in the air. That's why on a humid day, your body feels sticky and you have sweat because that sweat does not leave your body or evaporate from your skin. What does that mean? I want to show you a picture of what that means. Okay, give me 1 second. So if you see this picture right here, you can see there's a guy one day and a guy another day. Now on the right where my cursor is, this is a guy who's out on a day that's not as humid. How do I know it's not as humid? There's not as much water vapor present in the atmosphere. There's only 2 water vapor droplets. Obviously there's more on a typical day, but this is just an example. And because there's less water vapor in the air, your body can sweat, and that sweat then leaves your body. It evaporates from your skin and goes into the atmosphere. That's how your body becomes cooler. That's why we sweat, to try and stay cool when we're exerting on a hot day or exerting energy in general. When there's not a lot of gaseous water or water vapor in the atmosphere, then there's an instance or an opportunity for our sweat or the water on our bodies to leave. So when there's not a lot of humidity, if there's not a lot of water vapor, we can feel cooler because we can sweat and that water leaves our skin. That's why we feel colder. On a humid day, you normally feel hotter or you feel sticky. That's because there's more water vapor in the air. As you can see, there's six water vapor droplets present in the atmosphere this time. That's 3 times the amount of water vapor from our example on the right. Because there's more water vapor present in the atmosphere, our water doesn't leave our skin. Our sweat doesn't leave us. Instead, we still sweat because that's what our body does. But the sweat stays on our skin, making us feel sticky and hot and wet. That's what humidity does. That's why humidity feels the way it does. More water vapor present means our water can't leave us. The sweat on our bodies can't leave us as readily. You might get a couple of droplets off your skin, obviously, but you're not going to get it at the pace that you would have if it wasn't as humid. That's why you feel the way you do on a humid day. So that's what humidity is. Okay. Now, what is relative humidity? Relative humidity is the amount of water vapor present in the air compared to the maximum water vapor that the air can hold at a specific temperature. What that means is, at specific temperatures, the air can hold so much water. So relative humidity is almost like a fraction or a percentage. The water vapor is holding, or the air is holding 60% water vapor. So of the 100% water vapor it can hold, it's only holding 60%, or it's only holding 40%. It can only hold this much, but it's only holding this fraction of it. That's what relative means. Now, I told you at specific temperatures, air can hold different amounts of water vapor. Warm air can only contain half of the water vapor that cold air can. So cold air can hold more of the water vapor than warm air can. Twice as much, in fact. Warm air only holds half. So, what does that mean? I'm going to show you a visual. So if you look at our example here, this is one water vapor molecule. Now, in real life, we're going to have a bunch of different water vapor molecules, a lot of them, but it would confuse you more. So I just want to show you one example. If you notice on the left, we have cold, on the right, we have hot. Our water vapor molecule, or our gas molecule, our air molecule on the right can hold 2 water vapor molecules. But on the other side, where there's cold, the air can hold 4 water molecules. That's twice as many as the hot. Cold air holds more water than hot air. So it's going to be able to hold or have a higher relative humidity than hot. Lastly, we have dew point. Now, I want to point out before we talk about this, when you go outside in the morning and it didn't rain the night before, but you see water on the leaves, that's because it's dew forming. It's a condensation. Remember when we were learning about the water cycle, we learned what condensation was? It was gaseous water or water vapor turning into water, and those water droplets forming a cloud. On a hot summer's day, when you have a drink, you see liquid on the outside of the drink. That's also condensation. Condensation occurs when gaseous water vapor goes back to liquid form. That's when it gets colder. So the hot air touches a colder substance, it loses heat energy, or that thermal energy, and forms liquid. That's condensation. And that's what dew point, or what dew is. Dew point is the temperature at which air is saturated and condensation can occur. So dew point is the temperature. Dew is the liquid on the leaf when it hasn't rained, that condensation. Dew point is the temperature at which the air is saturated. So there's enough air in the atmosphere where condensation can occur. When air near the ground is saturated, water vapor will condense into a liquid. So that gaseous water turns into a liquid, condenses into a liquid. Higher up in the atmosphere, clouds will form. So that's how we get clouds. When the temperature is above dew point, then dew forms. When the temperature is below dew point, ice crystals form. So that's essentially like putting water in the freezer. So dew point is a specific temperature at which air or water vapor becomes water. Condensation can occur. If at that temperature the air becomes liquid, it's dew. But if it's below that temperature, that gas can still turn into a liquid, but it will actually skip the liquid phase and you'll get crystals or solid form. So we'll get ice. So the dew point's that temperature. If it's a little bit above that dew point, we get liquid. Or at that dew point, we get liquid. If it's below the dew point, we get crystals. That gas skips the liquid phase. and we're left with ice crystals. But what I want you to take away from this for right now, the big idea is dew is the liquid that has condensed from the water vapor in the atmosphere. Dew point is that temperature at which the condensation occurs. Okay, that's all we have for today's slides. What I want you to do is go take your notes, finish your notes, make sure you submit them, make sure you do part 2 of the exit ticket and submit that. Have a wonderful weekend. I will see you on Monday.